Alright, welcome back. So today I want to start a new project and it's gonna be a chess engine in C. And my idea for this project is to try and combine all the things that we've learned so far in terms of compiling C code to Wasm and being able to play with it in the browser, and also playing around with the min-max algorithm. We'll try to use those two ideas to have like a small platform where you can play uh, chess game against an AI, and hopefully it's gonna be, at least good enough to beat me, which you don't have to be good to beat me at chess. So yeah, let's try to have today, a board where you can just play random moves, and yeah, we'll try to have also an AI, and we'll get to some, strategies further down the line. But we need the basic, the proof of concept that we can actually play the game on a web page. And for the chess pieces, I found this Wikipedia page, which is pretty cool. We can just use this. We'll see for the board. I guess we'll just draw squares, but yeah. So what do we need as some dependencies? Obviously Node.js and Clang. And since I'm using Nix, I'm just listing them in the native build inputs or whatever for the Nix shell, but you can just sudo apt install them if you don't have them already. So yeah, let's try. And I'm not gonna do it, or at least I'm gonna do it in a more of a from scratch tutorial kind of way, because we already know that we can just copy paste this Webpack config and slap it on our project and it's gonna help. But let's just start with like the main intuition, going from a main.c file to actually being able to open it in a browser. So I'm gonna start with the usual stdio.h and printing hello world. So printf hello world, and then we'll try to figure out what commands do we need to run to compile to Wasm and actually open our stuff from the browser, right? So that would be pretty nice. So we get hello world, that's kind of cool. And if we create a web page, and let me just copy paste index.html from some other project because it's gonna be same thing, right? And in another terminal, maybe we'll just go to src and start an HTTP server. So we can go to localhost 6969 and we should see, we should rename it to chess engine. So chess engine. And if we refresh, we get this new web page. Okay, and you might be something like, okay, usually we need to create a JavaScript file and we might need to also include it. So let's add a script. src is index.js, and that means that we can go in here and maybe do a console.log hello world. Okay, so if I refresh the page, we should get hello world from the JavaScript. Nice. Okay, but then how can we maybe just define some functions without any main in C and have something like the sum function that gets a number and another number, and obviously it returns the sum of these two numbers. This is the example that I usually use with Wasm. I think it's pretty straightforward. It has two numbers. So what you can imagine Wasm does is compiling a C file into a DLL but that DLL is available from JavaScript, so you can actually load it in the JavaScript runtime. It's not like a DLL that you linked with at either at compile time or at runtime with some other C project. And you might remember that from our Connect 4, where we had this player module that we compiled to a DLL, and we had the random module that we compiled to a DLL, and we were able to load these DLLs from C by using this which was load move function. Okay, it was by using DL open and DL sim and whatnot, so we were able to load some DLLs from C code, but we want to be able to load something similar from JavaScript this time. That's the goal. Okay, so how we can do that? First step is to actually compile our C code into some kind of format, and I guess there is the magic command that compiles to Wasm. So what you need is to change the target to Wasm32 instead of the default one, which I would assume it's just Linux probably. Then we need some extra arguments that we need to understand. So first of all, there's no entry point in this file because it's gonna compile to a library similarly to DLLs and O files, some of them. Then we want to export all the symbols. That's because we want to be able to use this sum from JavaScript, so we have to say export all, or maybe there is something like export and then you specify the name of the symbols, but export all, it's easier. Then allow undefined, I would say maybe it's for the cases where you just define the header of a function, but I'm not sure. I just include it always. Then we have no standard libraries, which is because with Wasm you cannot use stdlib, you cannot use malloc or syscalls, because you have to think about it. It doesn't make sense to call syscalls because Wasm is not Linux, it's a different platform, so we have to use the functions for Wasm. So again, you cannot open files, you cannot write files from Wasm. It's kind of like that. It's a different kind of platform, so you don't have stdlib available on Wasm. We have to implement our own printing, our own memory allocation, so you cannot really use stdlib. That's the idea. Then some random other flags like std, werror, pedantic, whatever. These are just default ones that I use throughout more projects, so I'd say just to be there. And then we just output main.wasm. So if we run this command, from the src folder, we should see this main.wasm file appearing. Okay, that's pretty cool. But now how do we load this Wasm file in our JavaScript file? So we can just search for that, I guess. So JavaScript load Wasm module, right? And we should get this to this tutorial, and this is basically the main thing that we need. So let's just try to copy paste it. We have instantiate streaming, right? And here we can just say the name of our Wasm module, which is main.wasm. And for import object, this one I think it should be like an empty dictionary for now, like empty object. And the result is just gonna be the Wasm module. Okay, so how do we now access our function? So our function was called sum. How can we get it from the module? Well, we have to say something like value.instance.exports.sum, which is the name of our function. And finally, we can just console log sum 1059. And if we just refresh the page, we should see the sum appearing there. So it's basically calling to the C code from this JavaScript file, right, which is pretty nice. Now, maybe a difference that you can see between this Connect4 project and this current project is that here we are using JavaScript, but here I was using TypeScript, which I'd say it's better to just use TypeScript because it's, it has types. It's like an upgrade. It has all the JavaScript features, but something extra on top of it, so it's clearly better, I'd say. So let's try to change our index.js into an index.ts file. Now, obviously, this is going to be complaining here, but the important part is that it's no longer working because we don't have an index.js file. So we need a way to convert this into an index.js file. Okay, that's fair. So easiest way to do that is to install just install the TypeScript compiler. Honestly, I'm just going to copy paste this thing, or maybe we can build it step by step. I'm curious if TS loader gives me the TypeScript compiler. Let's just, so if we go back, npm install save dev. Let me just delete package.json and npm init. So I'm just gonna do everything like that. We don't really care. Oh, it actually found the description. That's pretty cool. Anyway, let's npm install ts loader. I'm just too lazy to install tsc directly. Let's see if it's actually working. We don't have tsc. Then if I install TypeScript like that, do I get tsc? Really? Node modules type. Okay, okay. So I have maybe I didn't need TypeScript. Okay, but this creates, the ts config, which I'd say maybe you don't need the entire thing. You just need some basics, and let's just copy paste the basics from some other project that I had. So module common.js, remove comments. These are just some random things that I had usually in my TypeScript projects, so I just trust them. So, now that we have TSC, it's pretty weird that I don't have access to it directly, but doesn't matter. Let's see what commands do we have. Oh, so it just runs. Interesting. So if I just run tsc, it should... Okay, yeah, nice. It compiles all the files. Perfect. But here it complains that sum is... it has a weird type, right? That's what it complains about. But it's nice that it actually creates this index.js. Which, weirdly enough, it complained about it, but... let me just delete everything. So one way to get around this error is to do something similar to what I did in my Connect4 project, which is to just define the type of a function, right? Just like this. And here I had a and b as numbers, and the return type as a number, and I called it sum function. And here you can just say as sum function. So we just assume that this sum symbol is a sum function, which I mean it is, but so we run tsc, and we actually get the index.js file that we were looking for. So if I refresh the page, now we get 69, and we are using TypeScript, right, which is kind of nice. And now you might be thinking, okay, we are doing a bunch of, running manual commands, like you have to run clang. Again, src, I have to change the path because I was changing paths. So you can see actually the annoyance, right? You have to run the commands, you have to make sure you are in the right directory. You run this clang command, then you have to run tsc, and then you are here. And one way to avoid this stuff is to just use Webpack as a build tool. And we created this kind of together, right? So we can just copy paste this thing, and this will basically run these two commands. So that's what you have to think about it as. It's just gonna run these two commands, and you can also, I think, have something like dev server, which watches your files, and if they change, it runs again, and you don't have to recompile it. But I don't know if it really works, haven't checked. So yeah, we can just create this webpack, then config.js, copy paste this thing, and I don't think we need to change anything actually, maybe except the name of the C files. Maybe, we have main.c, and for now we call it main.wasm, but the rest of the stuff we don't need to change it. So let's just delete the main.wasm, index.js, index.map, and we have just the basics, and we don't even need to specify this script here. We can just remove it because it's going to be added by Webpack itself. So that's pretty nice. Okay, and we can install save dev, the other stuff as well. So HTML Webpack plugin is for Webpack to be able to see the HTML files. Prettier is just prettier, just to format. TS loader does the TSC stuff for us, so it loads the TypeScript files. Webpack is Webpack. Webpack CLI and dev server are just, the CLI tools. And dev server, again, I don't know if it actually works. For me, it looked like it didn't work sometimes, but yeah. So we just install these things. I would actually remove node modules and reinstall them just to be sure. So I'll remove TypeScript and just npm install. And in my package.json, I usually also like to have some scripts for making things easier, like build, it just runs the build with Webpack. Serve, it runs the dev server. And prettier, just to format my config and stuff. So if I run npm run format, see, it should run the format in here. Don't like that. Do I have prettier config? I do have a prettier config. Nice. Okay, again, I was about to start ranting about tab width and semicolons and single quotes. Like, that's insane that someone can code. Okay, perfect. Do we have any other configs? I don't think so. Yeah, I mean, these are the configs that we need. Okay, perfect. So now instead of running all those commands, we can just say npm run build. And if we go into this directory, because this is going to contain all the stuff now, we can just start HTTP server and it should behave the same. And again, we can also run npm run serve, which should run the dev server. This dev server runs on 8080 though. And yeah, see, like with Webpack dev server, but it's kind of weird though. It's like if I change here something, it should reload, but it's kind of slow, I think. Where is it? Oh no, yeah, whoa, nice, it actually reloads really fast. Maybe the only problem is when I change the C file. Let me just do +1. See, like if I change the C file, it doesn't reload. Maybe there is like, I don't know, maybe there's a whatever. So if I change the C file, I have to reload it manually. That was the only part that I didn't like. So I can run build, and here we can start the HTTP server. Right on 6969, perfect. Okay, so then we should try to draw the chessboard, right? That would be the plan. So again, we could steal some functions from Connect 4. I'd say that's a pretty good strategy. Maybe exactly this kind of wasm.h. That's what we probably need, wasm.h. So okay, we basically have some functions like width and height, which are gonna give us the width and the height of the canvas where we draw stuff. Maybe we need JSRandom, which is a function that gives a random number between two A and B values. JS clear canvas, that's for drawing. Draw rectangle. Maybe a better name would be fill rect, because it's filling a rectangle with a color. This could be like fill circle. Okay, let's remove log message, we don't need that. Or maybe it's gonna be log C string, right? Like a C string that ends with a null character. But you know, we won't need many of these things for now. Let's just say we need log C string. Okay, so let's go back to our TypeScript file. Then something else that I saw people doing with Wasm is having this kind of W variable, which is gonna contain the instance of the Wasm module, like right when this value is loaded, we say W is equal to value, right? And then we can initialize our functions. Okay, that's fair. So let's pretend we still have this sum function, and then in here we have to define our environment. So for instance, env, and env is gonna contain stuff like our function for printing. So JS JSLog cstring. Maybe that was a bit of a difficult function to do first, but let's just pretend that yeah. So it's a void function. Okay, whatever. So it doesn't do anything for now. Maybe I also want to git init because it's annoying to keep. Do I have a git ignore? I do. Nice. Git ignore. Okay, that looks good. Let's initial commit this thing. Okay, perfect. So we have this JSLog cstring, and maybe something that's a bit weird is why cannot we have here message string? And I'd say that's because even though this looks like a string, it's actually a number because it's a pointer, right? It's actually a pointer because the C strings are just pointers to the initial character, and we have to search for the 0th, like the byte with a 0 in it. But for that we also need access to the memory, right? And yeah, whatever, we can just copy paste something like memory size. Okay, it's interesting. Right, so here you can see how I was doing it. So I was just getting the memory dot buffer on top of this W. So that's why I wanted access to W, right? Because in here we have access to the module, but in these functions we might also need access to the module itself because we need access to the memory sometimes. That's why I said maybe starting with printing was not the greatest idea because it's a bit more tricky to achieve because it uses pointers, and if you need to use pointers, then the pointers are just indices in this memory. So yeah, it's kind of annoying, but we'll be able to do it. Okay, so easiest thing to do maybe is to figure out the length of the string, because we just need to find a 0 byte, right? So we have an array of bytes. We need to go to the message index and then start to search for 0. So how can we do that? Maybe we can have something like let length is equal to 0, and you can see here I was doing something like this, right? I was taking a slice from the memory and I was using the length, but to be able to use the length we need to figure out the length, right? So maybe I can do something like while memory at message plus length is not 0, length plus equals 1. Maybe that makes sense. We are trying to figure out, like, this is string length, basically the string length function, right? But we are doing it in JavaScript. Like, sure, we could have said here, okay, give me the length, but I don't know. Let's just keep it like this. So now if we go to main.c, we could include wasm.h, and maybe do something like hello from C or whatever. And again, we need to run build. And now if we refresh this thing, it's gonna say hello from C. The only problem now is we cannot really have string formatting, which it's kind of sad. Like, I'm pretty sure log has a way to do formatting, but for some reason it doesn't work perfectly, so it's kind of, it's like util.format, whatever. So it's not the greatest way to format the messages. But I mean, we can try. At some point we can try to use to implement a log, like a printf function that actually works. Anyway, so the goal now is to implement these other functions like width, height, maybe random, clear canvas, and whatnot. And we can just copy paste them from my other project. So width and height are just returning the width and height values, which we actually need to do them as well. So let me just add here. So the width and the height, I would do them 800 by 800 because each square is gonna be like 100 by 100 and we have an 8 by 8 map. I guess that makes sense. Okay, and we can just create a canvas, right, with the width and the height, and that's that. And maybe even get context is a useful one. Okay, so we get context, and now we can use this ctx to draw stuff. Okay, so for now we have just the width, just the height. I mean, JSRandom is a good function to have in general, so I'm just gonna add it. It's just random. Then we have clear canvas. Maybe we'll need it. Alright, so it just clears the canvas. Draw rect. Actually, I renamed it, so it's JS fill rect. Right, so it's just gonna be the x coordinate, the y coordinate, width, height, and the color. And the color is gonna be a hexadecimal number, so that's what's happening here. Okay, and it does fill rect, so it's just gonna draw a rectangle. Cool. Then we have draw circle, which is also actually maybe just fill circle, and it does the same stuff. Actually, I don't even think we need fill circle, so we can just skip it, but yeah. What would be more interesting is drawing an image, so we'll try to do that. But yeah, for now we just implemented fill rectangle, being able to print stuff. We'll see how we can do more complicated stuff, but yeah, that would be nice. And the other stuff that I think would be cool to have is like this game loop, right? So I'm just gonna copy paste this entire game loop, and then the catch at the end, and let's just go through the game loop. So obviously it wanted an FPS, which, I mean, sure, why not? Const FPS, let's say 60. Then we initialize our W module, and then we need an init function and a tick function. I'm just gonna define them here. right? We need these two, init and tick. These are going to be the functions that we expose from our C code. So init is just going to initialize our memory allocator if we need one. I guess, I don't know if we need one, but we'll just initialize it. And it also, clears the canvas, maybe it draws some stuff. I don't know, it just does some initializing stuff. And then we call to tick each frame. And inside of tick, we might want to check for clicks. We might want to check for, I don't know, other stuff like that. And maybe, draw things on the screen. When pieces move and stuff like that. So npm run just to have the stuff formatted. Okay, so that would be all with the JavaScript side for now. We might want to add more functions like this, but we'll figure them out on the way. So let's go to our C code. So we just remove the sum function, and let's take a bit of a look at what we actually need to do. So we need this init again, and we need tick. These are the functions that we need to expose from our module. Okay, that's makes sense. And yeah, maybe renaming it to something different like game or UI would make more sense. But yeah, whatever. Because I was just thinking like, how could you change, or how can you change from one AI to another or stuff like that, but I don't think it matters that much. Okay, anyway, so again, usually inside of init I would just create an allocator, maybe draw the board, like the initial state of the board, and maybe the initial state of the pieces or something. So yeah, the other thing that I guess we might need is probably ds.h. Like, we might need ds.h. But to be able to compile ds.h, we need to define ostdlib. That's the first step. And then we need to define one allocator. So let's say the list implementation is what we need. And maybe these things too, just for now. Okay, then we can just define an allocator, and we can just initialize it with init allocator. Okay, perfect. So how can we now draw the board? I guess let's maybe take a look at the assets. We definitely want to include these assets in the dist build somehow. Maybe even calling to fetch somehow to get the PNGs. I don't know how we'll be able to get the PNGs. Or how do we want to describe a chess position? Do we want to use an 8x8 like 2D array? Or do we want to have a different kind of approach? Not really sure. I guess we can just choose one for the time being. Like maybe we just go with 8x8 2D array, and we'll figure it out if we need, to improve like a memory space or something. And then it's gonna be interesting, how can we load these things? Okay, so let's try to have a function similar to print board from here, and chessboard board. Here we don't have this thing, so let's define. Actually, it's gonna be just like a char 8x8, right? That's how I do it. No, is that rare? Okay. Wait, how do I? Oh, like that. Okay. So we have chessboard T. It's an 8x8 char array, right? That's how I defined it here as well. Yeah. Maybe I want to do like define chess size 8, or maybe chess width height, just so we know. Actually, I want height to be first. It was more annoying with height second because it was flipped. It was like transposed. Okay. And maybe we need to figure out some character codes for the pieces. But yeah, shouldn't matter right now. Okay, so how does the chessboard look like? I guess it starts out with like top left corner is gonna be white, right? And then it goes like that. So maybe we can have a for loop. So we go by row is equal to 0, row is less than chess height, row plus plus, and then we have column is equal to 0, column is less than chess width, column plus plus, and at this point, if a row is divisible by 2, we'll have some logic, else we'll do something else. Oh yeah, I mean, if the row is even and column is also even, we should print a white square. But for now, let's just have something like int, like canvas width is equal to js width canvas height, just height. Maybe something like cell width is canvas width divided by chess width, right? So that's gonna be the cell width, and we also need cell height, which is gonna be canvas height divided by chess height. And here we can call to fill rect. And I guess that's also an interesting point. Was gonna be the exposition, so I guess it's interesting. I didn't draw a rectangle there. Oh, I did. So it's column times cell width. I guess we can have here x is column times cell width, right? And y is row times cell height. So we do xy, cell width, cell height, and then for the color, it's gonna be white, right? So 0x. And on the else case, oops, we just do black. I mean, it's interesting. Here I just needed a color, right? So I can say something like int color 0, and then color is equal to 0 x ff. And here, if the column is divisible by 2, then we do black, and else we do white. And after this big if else, we can just do just fill rect xy, cell width, cell height, and color. I think it makes sense. So we can just print board. I guess I can just define the board somewhere here. It's weird having to call to npm to build a C project, but yeah, whatever. So if I run this thing, we should see it. We should see the chessboard appearing, right? So I think it's good. 1, 2, 3, 4, 5, 6, 7, 8. I think it looks fine. It should be like rook, horse, bishop, queen, king, right? Yeah, so it looks fine. Okay. Perfect. I guess in my connect for game, I was also doing, oh, so I can just clear canvas maybe in print board here. So there's the first step, clearing the canvas, and then we just draw. Obviously right now we are not using the board because we don't have any pieces, but that would be kind of the next step, I guess. So Wasm load image. How can we load an image. I mean, it should be more like I don't know, like passing the image name and then from the JavaScript we actually load it and fill it. So it should be maybe something like JS fill texture, and maybe we have like X, Y, width, height, and then const char pointer name of the texture, or like texture like that. So it's gonna be the name of the texture, because yeah, like that's what I would imagine, because obviously we cannot really load the images from the C code, we have to load them from JavaScript. So we need a way to do that. Okay, what about Webpack images, like asset management? So how can we, not CSS, maybe we have load images. Nice. So we could have something like this. We test for PNGs and whatnot, and it's type asset resource. Interesting. And then we can just import. Okay. I mean, that's enough with the images. So I guess what we could do instead is, let's say, mark this thing, mark target. We have them inside of our src, right? And what this thing tells me is I should be able to import icon from assets. Can I do that? Can I do something like that? But like for TypeScript. All right. So I should be able to create a new image and then append it maybe to the root, right? So I should be able to do something like that. Now the tricky part is how can we do it with TypeScript? And we need to add this thing in the rules. Okay, fair enough. That's okay. So we do it in Webpack. So just like we did it for, TypeScript and whatever, we need to copy paste the images in the dist folder. That's all this does, pretty much. So if we run build, I mean, it's complaining about this thing, but how can we avoid that? So if we check dist folder, we should see assets, right? And we should only have the one that we use. So bishop dark or whatever. Okay, so that works to some extent. What happens if we just reload this thing? Okay, so we have it here. But it complains about something. it doesn't like the image. Okay, interesting. Let's see, TypeScript import image. Pretty funny. How can we add an image? So import image to add. Fuck. The final URL. Just looking here. I mean, this is exactly our use case, right? It's a type resource, and then we just import that thing. I mean, it makes sense for SVG files to do asset inline, probably. It's really weird. Why didn't it work first try? That's a good point. So here you see it looks for undefined. The fuck? Oh, why undefined? So icon. Webpack, PNG asset, TypeScript. Let's see if this kind of works maybe. So declare. Okay, I mean it wants this kind of trash, maybe. Ensure that you have file loader. Index.d.ts. But I mean, won't hurt trying to create this file. And so we have to include it, okay. And can I just declare a module like this? So PNG with whatever. And then inside of tsconfig, I have to add that here, right? Index.ts. I guess. Yeah. Again, I'm not sure if you actually need file loader because it's already like working without file loader, and then it should work. Let's see index.ts. Okay, so now at least it's not complaining about this thing, but it wasn't even a problem, I'd say. So it's still showing here undefined, like what? Let me just restart this thing. So it's undefined. That's pretty nice. Let's import everything from there. I have to refresh it. Oh, let me just, because I just want to see what's inside of that module maybe. Okay, so interesting. That displays it as it should, right? So what would be, in which case you probably need to do that. Okay, let's see inside of this thing if I use this one. So this is like export is equal to value. Interesting. Actually, I mean, I have no idea what the fuck this does, but I mean, it's JavaScript, so it is what it is. Okay, nice. So now we have the icon. Perfect. GG. GG, bruh. So we should be able to import the icons like this. Right. That's perfect. We can maybe make like a module for that. Just looking here. I mean, fill texture. It's kind of annoying. Because the textures have to be loaded, kind of. It's not really that, oh, you can call to any texture. I mean, it could be even more specific, like fill piece, and I just give it X and Y. Maybe width and height, that's also a good idea. And then we could have something like char or maybe like int for the piece. Or maybe int piece and color. But you know, I'd like them to be chars, honestly, if that's possible. Like fill a piece. Although, yeah, that actually, I mean, No, we'll have just piece as a char. So my idea is, in here we have the chessboard is 8 by 8 char array. So we might have like something like white pawn is 1, black pawn is 2, and so on. So we'll have some defines. Nice. So let's go to index.ts. Maybe we'll have something like pieces.ts or like piece.ts, where we are gonna load all of these pieces. So yes, maybe we can just copy paste all of these in here and do something like this. So it's so it's something like assets, just whatever. So I think this is bishop dark from star as bishop light from star as knight dark from knight light from what the fuck is n? Okay, I might be wrong with the names. Let me check. So src assets, what's this? That's bishop, I was right. The k1 is king. It's not a knight, it's a king. Maybe n is the knight, I don't know. Yes, it's a knight. Okay, I guess this is a pawn with a p. Let's import the queen light, root, it's the rook. Okay, perfect. So now we have all of these pieces, right? And we can make maybe an array of them, and yeah, so something like export const pieces, and then we can have something like bishop dark, bishop light, king dark, king light, pawn dark, pawn light, the rooks, and I guess that should be it, right? We should have all the pieces now. And if we import pieces from piece, we can say something like pieces, pieces at 0, let's say. And if we build this thing, we should get that piece, or maybe, you know, if we go index 4, we should get another piece, and so on. That's pretty nice, right? Now the only thing is, I guess the pieces are 60 by 60. I'm pretty sure about that. So if I do file, src assets, any of them, it's a 60 by 60 image. So maybe we want to do 8 times 60 here, just so it's the same size as a piece. Although it's a bit small, but you know, you can zoom in. I don't know, maybe it's too small. Who cares? The pieces are piecing. Right. So how can we now have some kind of easier way of mapping these things? I mean, it's just like, okay, let's just copy paste this stuff. Let's put it into wasm.h. Maybe we should do something like define, and then I like 0, 1, 2, 3. Right? So maybe something like this is how we define the pieces. But like that's just for being able to draw them. So yeah. Okay, I guess the other problem is that maybe we should index them with 1 because I wanted to keep 0 for empty. Maybe that's what we have to do. Increase all these numbers by 1 because I want to keep empty as 0. But yeah, I mean, you know, let's just pretend that I'm gonna do -1, and I'm not gonna forget about that. Okay, so wasm.h, now we have this fill piece function that we can use. So it's gonna be similar to fill rect, but it's gonna be called fill piece. And fill piece has x, y, w, h, and the piece. All right. And at this stage, again, yeah, sure, fair enough. We can do 800 by 800. There's no problem. I'm not using that. And what I can do here, but it's really annoying that I need to -1. Whatever. Can we, at this point, canvas fill image? Can we fill an image? So we can create a new image. Let's just copy paste this stuff and let's see what happens. can we do it? So we have blueprint, the background image. We set the src to pieces piece -1. All right, and we have this onload function. Onload, we have ctx. What's this? Mm. Oh, so it needs this here. Oh. But I mean, it has the fuck. Looks kind of scuffed. Draw image. So it takes the image, the X, Y, and the width and the height. Exactly what I said I wanted to do, but so it's context, canvas get context, image, add event listener load, and then context draw image. Let's try to use context draw image though. ctx draw image. So it needs the image. Okay, fair enough, fair enough. I get it. So we have my icon, whatever, right? Here we have to say piece -1, and then we can do something like context draw image, my icon X, Y, W height. Let's call it image. And sure, maybe I need to do the onload stuff, but let's see if it works like this for now. I mean, we don't have any image, so fair enough. So inside of main.c, let's say we do JS fill piece XY cell width cell height, and let's say we put piece bishop dark. Nice. So it kind of works. I mean, it's kind of ugly that cannot really see them if they're on the dark squares, but yeah, whatever. Looks good to me. So yeah, I think that's a good start, maybe. Just being able to fill pieces, fill in the rectangles. It's more of an intro, to be honest. So yeah, I mean, maybe we can do more stuff. Like, I guess thinking about the project structure is not that big of a deal. This should be just the rendering part, and then we'll have a separate part for the actual like AI, because I don't really want them to be, you know, really mixed up. maybe we want to use the engine from the CLI somehow. So yeah, but I feel like it's it's a good start. So yeah, let's try to do some more stuff in the next one. So until then, see you.